Okay, number 5. When a nerve impulse lands on the unmyelinated neurolemma, it will open the sodium, it will open the voltage gated sodium channels, and it will cause depolarization in the axoplasm. And when the depolarization spreads across the axoplasm, it will make the nerve impulse jump from one node to another until it reaches the axon terminal. When it reaches the axon terminal, it causes local depolarization. And in the axon terminal, the local depolarization opens the voltage gated calcium channels, and it will diffuse the calcium inside the axon terminal. And then the calcium will activate the calcium calmodulin dependent protein kinase, and it makes the synapsin, and it phagocytes, and this one phosphorylizes synapsin protein, and the synapsin protein will dock at the release sites of neurolemma to release acetylcholine, and the acetylcholine is moved out through the process of exocytosis, and the acetylcholine in the synaptic space will bind with the acetyl-gated sodium channels of the sarcolemma, and it will open the voltage gated sodium channel of the sarcoplasm, and there will be an influx of sodium, and then it will generate action potential, and the action potential will open the voltage gated sodium channels to increase the polarization, and then the action potential will travel through the T tubules and spread out to the myofibril, and it will go deep down into the sarcoplasmic reticulum, and then the action potential will open the dihydropyrimidine receptors of the ryanodide receptor channel, and it will cause the stored calcium in the sarcoplasmic reticulum to be released into the sarcoplasm, and then the myosin head and the ATP will bind from each to one another, and it will cleave into ADP and P by the ATPase, and this in turn becomes elongated perpendicularly, but it is towards the actin filament, but not attached to it. And then the calcium and troponin C binds with one another, and the tropomyosin C changes molecular configuration to uncover the G-actin, and the myosin head will be attached to it, and the myosin head will tilt and drag its arm, dragging the filament, and this will create a power stroke, and then the myosin head will release ADP and P so that new ATP molecule can be binded with the myosin head, and because of this, the myosin will detach from the G-actin, and this will make it relax. And when there is relaxation, the calcium will be detached from the troponin C, and the calcium will go back to the sarcoplasmic reticulum by the calcium pump, and therefore no molecular contraction happens. It can also reach the Nernst potential of the sodium, opening the voltage-gated potassium channel and diffusing the potassium out of the sarcoplasm and into the ECF, and this will make it repolarized, and meaning that there will be an increase of negativity in the sarcoplasm. Therefore, there is no muscular contraction. It can also trigger the acetylcholinesterase in the neuromuscular junction to break down acetylcholine into acetate and choline. Therefore, there will be no binding of acetylcholine in the acetylated sodium channels, and therefore no muscular contraction happens.